Hi, I'm Cheryl Leach. In this problem, we want to find the equation of the tangent line to the graph of a function f at a particular point. Well, in order to find the equation of a tangent line, we need two things. We need the slope of the line, and we also need a point on the line. Well, because this is not just any line, but it's the tangent line, I'm going to get the slope by finding the derivative. So the slope is the derivative of my function f. Now the way we calculate this is by using our limit definition. So we have the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. We're going to start working on the inside and moving our way out. So the first thing we need to do is to evaluate my function when the input is x plus delta x. Well, my function tells me exactly what to do. It says take that input, square it, and then multiply by 1/2. So I have the limit as delta x approaches 0 of 1/2 times the quantity x plus delta x squared. The next thing to do is to subtract f of x, which means I'm going to subtract 1/2 x squared. Then I'll divide by delta x. And then if I can, take the limit. However, if I try to take the limit at this point, I'm going to end up with 0 over 0, which is indeterminate, and I'm not allowed to do that. So I have to figure out a way of rewriting this expression so that I can use my limit laws. Well, let's do a little algebra. I'm going to start with my order of operations and work with this squaring piece. So I've got the limit as delta x approaches 0 of 1/2 times the quantity. Now I'm going to FOIL this, and so when I do that, I end up with x squared plus 2x delta x plus delta x squared. Then I'm still subtracting 1/2 x squared and dividing the whole thing by delta x. Well, if I try to take the limit, I'm still going to get 0 over 0. So let's continue working with some algebra. I'll go ahead and distribute the 1/2 across. And I have the limit as delta x approaches 0 of 1/2 x squared plus x delta x plus 1/2 delta x squared minus 1/2 x squared all over my delta x. And at this point, I notice that I have a positive 1/2 x squared and a negative 1/2 x squared. So those will add together to be 0. And I can come up and say this is the same thing as the limit as delta x approaches 0 of x delta x plus 1/2 delta x squared all over delta x. Well, unfortunately, I'm still going to get 0 over 0 if I try to take the limit. But I notice in my numerator that both terms have a delta x, so I can factor that out. And I have delta x times the quantity x plus 1/2 delta x all over delta x. And now for the key step. I have a delta x in the numerator and the denominator that will cancel, which leaves me with the limit as delta x approaches 0 of x plus 1/2 delta x. Finally, I can take the limit, because as delta x approaches 0, the x just remains as x, and this term goes to 0. So my slope is x. Now, I'm actually interested in what happens at the point 2, 2. So at the point 2, 2, my slope is going to be the x-coordinate, which is just a 2. Now, to get the equation of a line, I needed two things. That was just the slope. I also need a point on the line. This part is much easier. The point was given to me. It's the point 2, 2. So now I'm ready to find the equation of my line. So I'll use my point slope formula. Y minus y1 equals m times the quantity x minus x1, and substitute in all the appropriate information. So y minus 2 is going to equal 2 times the quantity x minus 2. So I have y minus 2 equals 2x minus 4, and finally solving for y, I have y equals 2x minus 2. And this is going to be the equation of my tangent line. All right, let's take a minute and use a graphing utility to verify my answer. When you look at your graphing utility, the first thing I'm going to do is I'm going to enter two equations. The first one will be my function, 1/2 x squared, and the second one will be my tangent line, 2x minus 2. So 1/2 times x squared and 2x minus 2. When I graph these, I should get a picture of a parabola and a line. Now, depending on how your window is set up, it may not be a very good picture. Try using the window x going from -1 to 5 and y going from -1 to 5 as well. If you use this window, you should see a clear picture of this parabola and the point 2, 2, and the tangent line that goes through that point. I hope this was helpful. Thanks.